Magandang buhay! This is Teacher Zenny, Grade 9 Science Teacher. How are you today? Good to hear that! Before we proceed, do not forget to like, share, and hit the subscribe button and notification bell for updates about our latest videos. Starting with, I would like to remind you that our topic for today is an exciting and easy one if you know how to follow patterns and rules. Walang maliligaw kung marunong sumunod. Are you ready to learn? Let's get it on! Our objectives for today are define electronic configuration, discuss the rules in writing electronic configuration, write electronic configuration of elements, illustrate the orbital diagram for each atom based on their electronic configuration. Our lesson for today is about electron configuration. Let us recall our Bohr's model. Bohr said that electrons are found in orbitals around the nucleus. From de Broglie, electrons behave like waves. That is why we have the electron cloud because of the continuous movement of electrons in their orbitals spinning. What is an electronic configuration? It describes how the electrons are distributed in the various atomic orbitals. And when we talk of atomic orbitals, it is the space or region where electrons are likely to be found. This is our mnemonic device, which will help us in the distribution of electrons. What do you see? Yes, we have numbers, letters, and arrows. Are you curious now on how to use this mnemonic device? Let's have some more concepts to discuss. Quantum mechanical model. There are several energy levels occupied by electrons, and energy levels are represented by a positive number. As the distance from the nucleus increases, the number increases. We have here the nucleus, then we have the first energy level, the second energy level, and the third energy level, and so on. There are several types of orbitals that can occur in an energy level. Orbitals have a specific shape and are represented by a lowercase letter.
S suborbital is spherical. It has one orbital. The S suborbital contains 2 electrons.
We can relate this in a motorcycle rider that can have one back ride. 2 of them are riding and the other back rider should be accommodated because they will be caught by an enforcer.
P suborbital or principal. It has 3 orbitals. The p suborbital has 3 orbitals, therefore, it could have 6 electrons.
We can also relate
The d suborbital, or it is diffuse. It has 5 orbitals. D suborbital has 5 orbitals, therefore, it could have 10 electrons.
This is also like a 10-seater SUV. It cannot have more than 10 passengers because it will be overloaded.
F suborbital or fundamental. it has 7 orbitals and it could contain a maximum number of 14 electrons.
A regular jeepney can have 12 back passengers and 2 in front, together with driver, with a total of 14 passengers. But again, can a jeepney run if there are less than 14 passengers? Of course, yes. But if it's more than its maximum capacity, it will be overloaded and must be towed by a policeman, and worse, it may meet an accident.
Different energy levels have different types of suborbitals. The first energy level, or the S suborbital. The second energy level, it has S and P suborbitals. The third energy level, we have the S, P, and D suborbitals. And in the fourth energy level, we have the S, P, D, and F suborbital. Our atom has electrons, but how do the electrons fit into the orbitals and how are they distributed?
For our general rules, we have the Pauli exclusion principle. Each orbital can hold 2 electrons with opposite spins. The Aufbau principle. Electrons fill the lowest energy orbitals first. This can be explained by the use of our mnemonic device. There. You can see that the mnemonic starts with 1s, then 2s, 2p, 3s, 3p, 4s, 3d, and so on. We can use the arrows for the correct arrangement of the distribution of electrons, and take note from our quantum model that s orbital can only have 2 maximum electrons, p is 6, d is 10, and f is 14, depending on the number of electrons to be distributed. The third rule is the Hans rule. Within a sublevel, place 1 electron per orbital before pairing them, or filling up available orbital before pairing. So the first 3 boxes in there, you see that there is a pairing of electrons, but there is still another vacant box for the 4th electron. And in the second 3 boxes, we have fill in the available orbitals, then we pair. That should be it. We have here an example of electronic configuration, but what are its components? We have there the symbol of the element. Then we have the atomic number, which is equal to the number of electrons to be distributed.
Number 1 in here, it's the number that designates the number of principal shell. We have S is a letter that designates the subshell. Number 2 here is a superscript that designates the number of electron in that particular subshell
or orbital. I have here an example of an electronic configuration. Oxygen with 8 electrons, or it has an atomic number of 8. There. So we have 1s2, 2s2, and then 2p4. If you are going to count the electrons there in the 1s2 and then 2s2 and 2p4, it's equal to 8, which is also equal to the atomic number. Its orbital diagram, we have there orbital for the s, We have 1, but it has 2 opposite spins or 2 electrons. Then we have 2s, 1 orbital, but it has 2 electrons. And then we have there 2p with 3 orbitals containing 4 electrons. Counting the arrows or the electrons, it is equal to 8. To sum up, electronic configuration describes how the electrons are distributed in various atomic orbitals. And in writing this electronic configuration, we had 3 rules. The Pauli's exclusion principle, which says that each orbital can hold 2 electrons with opposite spins. We have the Aufbau principle. Electrons fill the lowest energy orbital first. Then we have the Hund's rule. Hund's rule. Within a sublevel, place 1 electron per orbital before pairing them. Let's do this. We have here electronic configuration of potassium, which has an atomic number of 19. So using our mnemonic device there, we have 1s2, 2s2, 2p6, 3s2, 3p6, and 4s1. And here we have its Aufbau. 1 orbital for 1s with 2 electrons. For 2s, we have also 1 orbital with 2 electrons. Then we have, for the p, we have 3 orbitals with 2 electrons for each. So we have 6. Then we have 3s. It has 1 orbital with 2 electrons. Then we have the 3p. So we have 3 orbitals with 2 electrons each. Then the last, we have 4s. We have 1 orbital, but it has only 1 electron. That's all for today, students. And before I sign off, I leave this saying to all of you to ponder. When rules are followed, directions lead us to the right path. Again, this is Teacher Zenny saying, keep safe and good day. I hope you enjoyed our lesson for today. Bye-bye!